As we begin to explore networking, we run across this idea of subnet masks. What are they? What's their purpose? How do they work? So let's start with this question. What is a subnet mask? In IPv4, a subnet mask is 32 bits long, the exact same length as an IPv4 address. This subnet mask works with the IPv4 address, and it helps determine the network address and the host portion of the address. So let's take a look at how this would work, and we'll look at it both in decimal and then in binary, which is the way the computer actually looks at it. Let's take this address, 192.168.1.12, and let's give it a subnet mask of 255.255.255.0. Now in this case, the network portion of our address is going to be this right here, 192.168.1. And we know that because our subnet mask is 255.255.255. Remember, this actually happens in binary. We're going to take a look at that in a second. The host portion of the address would be this. It would be the .12. And that's determined by this 0 in the subnet mask. So let's see what this is going to look like in binary. Now we're going to start with an IPv4 address and a network mask or subnet mask. Now these are not going to be full, we're just going to do part of a pattern in order to illustrate the idea. So our IPv4 address is going to be 1011.0101, and our subnet mask is going to be 1111.0000. So we're going to find where the subnet mask's list of ones end, and right here between the ones and the zeros in the subnet mask, we're going to draw a vertical line. Now everything to this side of the line then becomes part of our network address, and everything to this side of the line becomes part of our host address. Now, this brings up an interesting point. There is a rule that governs subnet masks, and that is this. Subnet masks must always be a string of all ones followed by a string of all zeros. So this 11000000 would be a valid subnet mask. So would 11110000. So would 11111100. However, 10101101 would not be a valid subnet mask because it does not follow this rule. It's not all ones followed by all zeros. So because of this rule, only certain values are allowed to be in a subnet mask. In fact, if you remember our binary chart, 128, 64, 32, 16, 8, 4, 2, 1. You remember our binary chart, what happens is if we have all zeros here, it gives us a value in decimal of 0, and that's a valid value for a subnet mask. So is 100000000, which gives us a value of 128, and 11000000, which gives us a value of 192, and so on and so forth. In fact, our valid values for a subnet mask that we'll see in decimal are only going to be 0, 128, 192, 224, 240, 248, 252, 254, and 255. Anything other than that string of numbers is not valid in a subnet mask, because they are the only values that represent a string of all ones followed by a string of all zeros. So let's take a closer look at this in decimal. 255 in decimal is a string of all ones in binaries. 0 in decimal is a string of all zeros in binaries. Anything else, any of these other values, 128, 192, 224, 240, 248, 252, 254, these are all ones followed by all zeros. So what'll normally happen is our subnet mask will start out with 255. It doesn't have to, it can start out with any other of the other values, but it normally starts out with 255. Once we have a non-255 value, let's say 224, every octet after that has to be 0. So we end up with a subnet mask of 255.255.224.0. We could also have a subnet mask of 255.248.0.0 because everything that comes after 248 is all zeros. We could also have a subnet mask of 255.255.255 255.240. This would be a valid subnet mask as well, because it's a string of all ones followed by all zeros. However, 255.192.255.0 would not be a valid subnet mask because it is not a string of all ones followed by all zeros. In the 192 octet, there are both ones and zeros, so it breaks the rule. So hopefully that gives you a better idea of what subnet masks are.